Hi everybody, I'm Andy Smith, a principal architect in the Cable, Broadband, and Media Group here at Cisco. And with me today is Matt Gillies, our Chief Architect for Global Systems Engineering at Cisco. And we're going to have a conversation today about the role that compute plays in next-gen modern cable networks. Compute is becoming an integral part of any new service provider, but especially a cable network. But what computation really does is it provides a stateful transformation of data. We're used to servers providing infrastructure such as DNS or email, but more and more computation is being used to transform data to add value to it. We see this happening a lot in cable and in service provider networks. And that value added process can be enhanced by reducing the latency to get to the computational resource. So when we're exploring new architectures and cable networks, a new thing that we're going to have to consider is how much latency is there between the subscriber and the resource that's providing that computational transformation of data. Latency is something that we're going to be able to monetize in cable networks for the first time. We've never really had to factor this before. The cable industry has done a very good job of delivering a lot of bandwidth to a lot of homes at very high scale and doing it very efficiently. But we've never really considered the round trip time that a packet takes while it's on the wire. This is a direct correlation to the topology of the network. The more distance between the home or the subscriber or the end user and wherever that computational resource lives, the more physical distance, the more latency or time it will take to get a processing request done. This is directly correlated with the speed of light. We can't change the speed of light, but we can change the topology of these networks, and we can come to some key decision points when we lay out next-gen technology in cable networks. Some of the applications that are really going to matter for low latent, high bandwidth compute, or even low latent, low bandwidth compute, are real-time services such as speech to text, real-time face recognition. There's some very interesting ad insertion technology out there that's bespoke for a subscriber that would benefit from low latency. Just today, there was a report out from Gartner that said Secure Access Service Edge will benefit from a low latent edge compute strategy. So there will be a market for computational resources that can reach many, many subscribers quickly. And the question we have, and the question we want to pose to the cable industry is, how best do we take advantage of this? And key to that decision process is, where do we place the next-gen software CMTS, or what Cisco is building as a cloud-native broadband router? Where we place the CMBR is going to be critical, because when we centralize software like the CMBR, we do gain efficiencies of scale and we do gain some operational benefits, but we give up the degree of latency or short round trip times that we might gain if it were more distributed. Simply by centralizing it, we induce more time into the system, which sets an artificial ceiling or an artificial floor on how low the latency we can push. Low latency could also be a product that the cable industry could offer. It's really kind of one of the last things that we can monetize potentially in these networks. We're already at a de facto surplus of bandwidth. There's a lot of bandwidth in the downstream. The upstream is being actively worked on, and that's a product of today's environment of work from home. But latency is absolutely something that we can consider and plan for as we lay out new networks. And key to that may actually be the current real estate and the current topology of cable hub sites. There's been a lot of effort lately in collapsing hubs or perhaps retiring some of these hub sites, and I get it. Some of these hubs are not necessarily Class A data centers, but just by virtue of their location and their physical distance to a set of subscribers, they very well may be worth reinvesting in and migrating their use case from a center of analog cable equipment to a center of computational resources and more like a co-location center. There's lots of options when we deploy remote PHY. These same concerns exist whether it's a remote PHY architecture or a remote MAC PHY architecture or any flavor of FMA in between. All those architectures are bookended. I have a node in the field and I have either a CCAP core or an S-leaf or a router at the other end. Where we place those resources directly correlates to what kind of low latent high performant network we can get. In the rest of the metro network, there's a lot of new technology coming in the form of a routed optical network, or what that means is next generation pluggable optics at 400 and 800 gig and next generation forwarding silicon. Why that matters is that we can move away from a strict hub and spoke IP topology. and we can build a much more meshed, routed driven network that'll permit us to place compute arbitrarily across the cable metro. This can help us place compute where the latency and the placement of that latency matters most. But one of the hardest things that we're going to have to address is the skill set, the automation, the people that are required to make this happen. This is not going to be an easy journey. It's going to be difficult. But if we want to mine the data and produce the return of these networks that is demanded in a modern environment, we're going to have to learn to adapt on how to merge computation and networks together, learn where to produce versus transit a bit, and learn how to provide a service that really can bring about some next gen services that are quite lucrative. And now to join me in a conversation, I'm pleased to welcome Matt. Matt, thanks for joining me. It's great to have you here with us for our conversation. A lot of people talk about low latency as a product or as a desirable attribute of networks these days. In fact, just today I was reading a Gartner report about secure access service edge, and it calls itself for low latent access to computational resources. In your adventures around the world with other service providers in and outside of cable, what do you see as the role of compute and the role of next gen networks in delivering new services?
Thanks, Andy. Great to be here. I think we're really at a time where there's been a significant change in both the network architectures and the technologies that we can apply to them. And cable operators really have an enormous opportunity to leverage their strategic assets, namely their footprint and their customers. And as you point out, really a number of the new applications and trends in the way that networks are being built directly impact the way that the services are going to manifest themselves. So what we've heard from customers is really the internet is the new corporate network. And as you point out with SASE and other applications like SD-WAN and collaboration solutions, there's a real desire and dependency for latency to be deployed much more strategically in service provider networks.
And do you see that around the world that that's a pretty common theme, or is this something unique to the States? Is there something about our networks in the US that might not benefit from latency, or how do we compare with the rest of the world?
I think this is a global phenomenon, and we're seeing really customers accelerate their digital transformation and the adoption of collaboration solutions, which, as you know, require really tight latency, security solutions, SD-WAN solutions. They really require this optimal network performance. So globally, across all market segments, across all types of customers, latency is really strategic and critical for these new services.
Right. So as computation becomes more of an integral part of these networks, one of the concerns that I hear from our customers here in the States is there's going to be a merger or a confluence or a conflict among skill sets that, just as we saw between packet and optical and DOCSIS and IP, that, this new merger of computation and network is going to be yet another hard thing to get people to wrapped around. How best for our customers in cable here in the States to adapt their staff and adapt their skill set for this new kind of cloud computing or software world?
Yeah, I think you're absolutely right. What we're seeing is really what were traditionally IT skills now making their way into the service provider. So there's certainly a requirement for service providers to invest in cloud skills, automation skills, how they use virtualization. So they're building infrastructure in a very different way, and they've had to really kind of adapt and change the way that they've built networks traditionally. And I think, as you pointed out in the opening, that really starts with automation. We really have to move away from the swivel chair and ruthlessly automate everything in the infrastructure, and then expose all of the resources in the service provider network via a common abstracted model that can be accessed really with an API.
Right, right. That's key. I mean, it's our job at Cisco to build devices that are automatable first and foremost. And the customer can choose to automate that however they want. And of course, we supply software that can do that, but they can do it on their own too. Many people may not know, but you actually played a pretty important role in formulating the software strategy for Cisco's cloud native broadband router. Can you just talk a little bit about the cloud native software architecture and its paradigm and what the benefits are to a cable operator to embrace that style of a computation system?
Absolutely. I think that, when we talk about the cloudification of traditional service provider services and functions, really to do that right, you have to do that from the ground up. And ultimately that means you're rewriting a CMTS and you're applying new architectural principles, you're using a new programming language, you're using new tools. And so we literally looked at how we built a CMTS in the traditional manner on a real-time dedicated appliance. And then we've rewritten all of those individual applications so they run in a cloud environment. And really the benefits that we get there is certainly around modularity, where now we can iterate some of the components individually, but really it's one of agility and scale. We can change any of the one components without affecting others, but we can scale the system horizontally instead of vertically. And by doing that, we leverage a lot of the economic and strategic benefits of the cloud.
Absolutely. And the last thing I'd just like to bounce off of you, this moment in cable feels very much like 20 years ago when we built the very first triple play networks, voice, video, data. And back then, a triple play network was difficult and hard, and a triple play in baseball is difficult and hard. No one today would argue that converging voice, video, and data was the wrong thing to do. In fact, it was absolutely the right thing to do. But we almost see the same trends today, where do we build disparate networks for disparate services, or do we embrace convergence again? And we see this in the role of computation, the role of optics. Is convergence a common theme among service providers worldwide, especially in the States? Or is there still some silos going on that we're going to have to overcome in terms of next technology?
I think, I mean, it's an excellent parallel to draw, and I think that absolutely we need to continue to break down the silos. And arguably, 10 or 15 years ago, we did a pretty good job of collapsing some of the silos, and now we really have to do that across service domains. And as you can imagine, there's certainly operational benefits and costs that service providers will gain as a result of doing this. But it's about agility. It's really about leveraging the strength of the entire portfolio so that we can offer services from a common platform. And really the only way we get there with the right cost and with the right agile principles is to break down those silos in those domains.
Absolutely. Well, thank you, Matt. Thanks for joining us for a little bit today. It's a great time to be at Cisco and a great time to be in cable. And thanks everybody for watching.
Thanks everyone. Good seeing you, Andy.